What is up, everybody? It's Dan from SageMathTutoring.com, soon to be SageMathTestPrep.com, but I have not switched it over. But nonetheless, this is a video for those of you who are taking the SAT, and more specifically, it has to do with SAT math. Now, obviously, there's a lot to be said about the SAT math section in general. This particular video, nonetheless, has to do with the various formulas that are good to know and or necessary to know on the SAT math section. And I began by just posting what they actually give you in the SAT math section. So many of you who have been studying, or maybe you've taken a test or taken a practice test, you realize that at the beginning of each math section, they give you these formulas here. I'm not going to go over these today. I'm probably going to go over them in a separate video, but just know for this video that these are the formulas that they give you at the beginning of each math section. Circle, the area of a rectangle, area of a triangle, and so on. Number of degrees in an arc in a circle is 360. So this is all stuff that they give you. Okay, and again, maybe I'll get to that later, but for now I want to go over the stuff that they don't give you, the stuff that is very good to memorize or have a sense of or have practice with. Okay, so moving on. Okay, so the first thing you need to know is the slope formula. Now, as many of you know, the slope is the rate of change of a line. And let's imagine you have a point here at -3, 7, and you have a point here at, looks like that's 3, 1. It's possible that they'll ask you for the slope in between these 2 points. And let's just be very clear, this point, or one of the points at least, is -3, 7, and another one of the points is 3, 1. So the way that this works is you're going to use, again, the slope formula. Now, what is the slope formula? The slope formula, which you definitely should know, is m equals y2 minus y1 all over x2 minus x1. So that's something you definitely need to know. Now, you might be asking yourself, okay, well, what is y2, what is y1, and so on. And basically what they mean by that is, let's say you have these 2 points, and maybe mentally, at the very least, you could label this one x1, y1, and this one would be x2, y2. And then you would just plug in these numbers where they belong here, okay? So let's focus on doing that right now. So we have m equals, I like parentheses. I just draw like the exoskeleton of everything first with parentheses, and I just fill in the parentheses later. I know it's going to be something minus something, up top, and it's going to be something minus something down below. So what belongs here? Well, clearly y2 belongs here. Well, what is y2? y2 is 1. And what belongs here? Well, that would be y1. Well, where is y1? y1 is right there. That is 7. Similarly, down below, what belongs here? Well, that would be x2. x2 is 3. And then if you were to look closely, x1 is -3. Now, by the way, that's one of the reasons why I use parentheses, because do you see how it's minus -3 right there? Without the parentheses there to sort of separate this -3 from this subtraction symbol, you may have made a careless mistake where it looks like these two subtraction signs or negative signs sort of blended in with each other. And you would have made the mistake of thinking that it's 3 minus 3, when the reality is that it's 3 minus a -3, and whenever you subtract a negative number, it's really the same thing as adding. So this is going to turn out to be 3 plus 3 as a result of that. So speaking of which, let's kind of work it out over here. So 1 minus 7 is -6, all over 3 plus 3, that is 6. And then if we were to simplify that, that would be -1. So that right there is the slope. To be thorough, I'll kind of write that, and I'll draw a little box around it. So we had 2 points. We were given 2 points. Maybe they'll, put it on the graph itself, and you have to sort of figure out what the coordinates are, and then you just plug it into this formula in order to figure out the slope. All right. So the slope is the rate of change. That means it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And if you kept going, you would eventually, hit the points. All right, hit that other point. And hopefully that makes sense. So what I'd like to do right now is, with each of these sort of explanations, I'm going to give the viewer, in this case you, the viewer, I'm going to give you a practice problem to try on your own, because it's one thing to just listen to these and be like, I get it, okay, next concept. It's a whole other thing to actually get at least a little bit of practice in, you know, before you move on to the next concept. That's what really helps you retain the information. So let's have me keep this on here. So I'm going to keep this here for you, but I'm going to erase everything else, and I'm going to challenge you with 2 more points. Okay, so the points in question are this one right here and this one right there. Okay, so this is basically the format that we're going to be doing for the rest of this entire video. I'm going to ask you right now to pause this video, try the problem yourself, and then when you unpause it, I'm going to demonstrate how to do the problem, and then you can check your answer. Okay, so go ahead, pause the video now if you'd like to try this problem. All right, so I am going to show you how to do this. So the real question, at least at first, is what are the points? Okay, what are the points? I know it's going to be parentheses with a comma. This point right here is 2, -4. 2, -4. This point right here is 6, 5. 6, 5. Awesome. And then once again, just going to really use the formula. Again, empty parentheses. I don't really care what goes in them just yet. I know it's going to be something minus something all over something minus something else. And let's call this x1, y1. Why the heck not? x2, y2. And what is y2 for this spot? Y2 is 5. And y1 is -4. Being careful with the negatives. X2 happens to be 6 and x1 happens to be 2, so it's going to be 6 and 2, and working this out would give us the following results. We would end up with 5 minus -4, aka 9, and 6 minus 2, also known as 4, and that actually is the slope right there. M equals 9/4. And notice how it's positive. It's going up from right to left. Now, could you count it? Yeah, you could count it. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 4. Right? So could you have counted it? Yeah. But you know what? I don't know. In my opinion, that's kind of conducive to careless mistakes. So it's good to know this formula. Anyway, moving on. Okay, how to write an equation of a line. So first of all, on the SAT, you definitely should know the slope-intercept form. That's y equals mx plus b, where this is the slope, and this right here is the y-intercept. And what do we mean by that? Well, here's what we mean. Imagine we wanted to graph the following line. So I'm going to move this over here. Imagine we want to graph y equals 2/3 x plus 2. Now, despite the fact that we're all used to going from left to right just in general, for graphing lines that are in slope-intercept form, you're going to want to go from right to left, actually. So we actually start with this 2 right there, and what does that tell us? Well, that's the y-intercept, right? Because the y-intercept is this constant that's kind of off to the side. Well, that tells us where to put our first point. We want to put the first point on 2 on the y-axis. So there it is. The point is on 2 on the y-axis. By the way, this is the y-axis in case you forgot. This is the x-axis. And then this tells us what the rate of change is. You know, it's the slope, right? This is the slope. It's the coefficient in front of the x. It's not the x itself. It's the number that's currently multiplying, being multiplied to the x. And in this case, it's 2/3. Now that is rise over run. Okay, rise over run. That's how slope works. And in other words, the top number tells you how much you're going up or down, and the bottom number tells you how much you're going to the right or left. If the top is positive, that means you're going up. If the top is negative, that means you're going down. If the bottom is positive, that means you're going to the right. And if the bottom is negative, that means you're going to the left. So again, in this case, we are going up 2 and then over to the right 3. Well, where from? Well, from the point that we just did. We're going to go up 2 and then over to the right 3. So putting our next point right there. And if I had a ruler, I'd have a perfectly straight line, but in this case, I'm just going to kind of wing it. And that would be the line right there. Now, for more accuracy, and if you didn't have a ruler and you wanted more accuracy, you could keep going. Actually, you could go up 2 over 3, up 2 over 3, and keep going, and then you just connect all the dots. So that's that. Now, you might be sort of expected to work backwards as well. For example, imagine they had a line right here that's down here, and then it's like cutting through like that, and we know for a fact that it hits this point as well, and it cuts through like that. Well, one thing you could do is you could take note of the y-intercept. It's -5 in this case, okay? And you could take note of the slope. It goes over to the right, or it goes, I should say, down 1, and then over to the right 1. Down 1, that's a -1, over to the right 1. Down 1, over to the right 1. So that one, in red, would be a slope of -1 over 1 x, and due to this y-intercept down here, that would be -5. Now, this is perfectly valid. However, you might want to just simplify it as -x minus 5. All right, so that is the second line. Okay, hopefully that makes sense. That was us working backwards, right? We took note of the y-intercept, we took note of the slope, and we just kind of plugged it into this format right here. Okay, so please, as a practice problem, we have a point right there on that 7, and we have another point right here on that 2, and please write the equation of that line. So please pause the video now, give it a shot, unpause it when you're ready for the answer. All right, so here is the answer. Let's take a mental note of the fact that the y-intercept is 7. Okay, so that's good to know. In fact, you could even write that. You could say B, y-intercept, is 7, because B is the y-intercept, so B is 7. So what's the slope? What is m? Well, we could always check out the rise over run scenario. Apparently it goes down 7 and then to the right 2. So that's going to be a -7 over 2. And then eventually we could write the final answer in the following way, where it's y equals -7 over 2 x plus 7. Some of you might be wondering, could I put the -7 up top, or should I put it down below? Well, I'm just going to tell you, let's analyze -7 over 2. That was, a rise of -7 and a run of +2. Now, I will say that could have also been rewritten as a +7 over a -2. These are actually equal to each other, because you could have thought of it as going up to the 7, up 7 steps, and then to the left 2. Think about it, because imagine we started here. You would go up 7 and then to the left 2, and it would still result in that same nice negative slope. Now, I will say the textbook, or the teacher, or your worksheet, or the answer choices on the SAT might write something like that as a negative with the dividing line right next to it, 7 over 2. But the one thing you got to know is, it's a negative fraction. That's a way of thinking about it. But this negative right here, it's either such that it gets applied to the bottom, or it gets applied to the top. But the one thing that's for sure that does not happen is it does not get applied to the top and bottom. And the reason for that, as many of you probably are guessing, is because these would cancel, and that would be a +7 over 2 as a result. Okay, this is a not equal sign. It's like this equals that, but it doesn't equal this, and it doesn't equal that, okay? Because it's +7 over 2. We're looking for a -7 over 2. So all of these work with each other. These are literally 3 different ways of writing the exact same negative fraction. Okay, when you focus on these 2 ways, it's a little easier maybe to graph, because again, you could go down 7 because that's the rise, and then to the right 2 because it's a positive 2 down there. Okay, same with that. Really depends on which one you prefer. I tend to like the negatives being up top. Anyway, hopefully that makes sense. Now, there is this kind of weird scenario where occasionally you're going to get like a line that's like y equals 3x. Okay? And it's like, okay, that looks a little different than this. First of all, there's no b, right? But here's the crazy secret. The crazy secret is that there is a b. It's the invisible 0 that's hanging off the edge right there. That's the y-intercept. Okay? That's the y-intercept. And this is the slope. You might be asking yourself, okay, the slope is 3. What the heck's going on with that? That's not a fraction. How am I supposed to know what the rise over run is? Well, as many of you watching probably know, there is an invisible 1 underneath that 3. So therefore, it's a rise of 3 and a run of positive 1. Okay? So you go up 3 over 1. So, for the sake of being thorough, let's look at that right now. We're going to obnoxiously zoom in to this graph, and in case we needed a reminder, once again, the line in question is y equals 3x. Well, we already decided that the y-intercept is 0, so as soon as you know the y-intercept, I mean, it's totally going to be okay to just write it there, okay? So we're not at y equals 4. We're not at y being -8. We're at y of 0 right there. And then you're going to go up 3 and then over to the right 1. So we're going to be here. We're going to be here as well. Let's get a little bit accurate here. We're going to be down here. We're going to be down here. We're going to be down here. And amazing. Look at that. Unbelievable. So that's how you do those. I'm not going to worry about the practice problem as long as you understand the general principle. This is in the form y equals mx plus b. It might just not look like it at first glance, but there's that invisible 0 hanging off the edge. I think you get it. Let's move on. Midpoint formula. Imagine you're given 2 points like that. And, you know, you could graph it, you know, you could graph it, you'd be like 1, 7, that's right here, 3, 10, that's like right here. You could graph it, but they want the point that's between these 2, you know? And so the question is, how do you do that without graphing? Well, it's actually not that bad. You need to remember with the midpoint formula that it's kind of a weird formula that like really begins with the end in mind. And that is because it starts with these big parentheses with a comma. And this is going to be the x-coordinate of the midpoint. This is going to be the y-coordinate of the midpoint. And as far as like what goes here, though, we're going to have these 2's down below. We're going to have x1 plus x2. And we're going to have y1 plus y2. In this case, you know, the order doesn't really matter here because it's addition. But whatever, just go x1, x2, y1, y2, and very similar to the slope formula, you know, you could conceive of this being x1, y1, and this could be x2, y2, and then you just plug it in, right? You just plug it in to the formula, no big deal. Let's do it right now. All right, I'm once again drawing the exoskeleton of this thing. I know it's going to be something plus something, and again, this is just me. If you don't like this, that's fine. But I find that it helps me avoid careless mistakes. For example, if that was a negative, it would be plus a negative. So yeah, so we would have what? X1 is 1, X2 is 3, Y1 is 7, and Y2 is 10. Amazing. Moving on with the next step. And that gives us, let's see, we have 3 plus 1 is 4, and 7 plus 10 is 17. So we're going to have 4 over 2, comma, 17 over 2, and that equals 2, because 4 over 2 is 2. 17 over 2. Now, we could always leave it like that, or we could, you know, find the decimal, and that's going to be 8.5. Okay. All right, so I hope you understood that. That's the x-coordinate of the midpoint. That's the y-coordinate of the midpoint. This is the midpoint formula, and I'm going to erase some stuff, and I'm going to give you more points to work with so you can try this yourself. So please find the midpoint of these 2 points. Isn't this fun? Not at all. I don't mind it. Okay, so -3, 7, 4, 10. Please find the midpoint of those 2 points. Pause the video now and give it a shot. All right, so hopefully you tried that, and we're going to try it right now. I know it's going to be a 2 down here, it's going to be a comma, it's going to be 2. I know it's going to be something plus something, something plus something, and what goes in this thing? Well, that would be -3, we would have 4, and then we'd have 7, and we'd have 10. Looks like we're gonna get 17 again on the y-coordinate. So we have -3 and 4. That's going to be 1 over 2. And then we're going to have 17 over 2. So it's going to be 17 over 2. I'm actually going to leave it like this. I mean, we could be like 0.5 and 8.5. But it's okay to have fractions too. That's actually the midpoint between these two. Hopefully you got that. Moving on. Distance formula. All right, so this thing is, for those of you who have learned this, it's the one where it's the huge square root symbol. Okay. Now you might ask yourself, well, what's it used for? Like, let's slow down a little bit. Well, it's used for finding the distance between 2 points. I mean, imagine you had 1, 3, and you had -4, -2, and you weren't looking for the midpoint between these two. That's where the last formula, came in. What we are looking for is the distance between these 2 points. Right? Now, you're going to want to, have a way of doing it that doesn't rely on you graphing it and then counting or estimating or using a ruler, right? So that's where the distance formula really does come into play. And bottom line is, distance formula is, yes, this huge square root symbol, and then it's these parentheses squared, and then we're going to have x2 minus x1, and we're going to have y2 minus y1. Okay, now what is x2 and x1 and all that stuff? Well, just like we've been doing, you just label the points. Now you might be asking yourself, could I have labeled this x2, y2, and could I have labeled this x1, y1? And the answer is yes. Okay, doesn't matter which one you call x1, y1, you just pick one and then call the other one x2, y2. So let's try it with this. Once again, parentheses, 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 parentheses. Okay, what's it going to be? It's going to be x2 minus x1. So it's going to be -4 minus 1. -4 minus 1. Okay, and y2 minus y1, that's going to be -2 minus 3. -2 minus 3. Okay, now this is where your PEMDAS skills really do need to come into play, because according to PEMDAS, which I'll write right now, PEMDAS, here it is, PEMDAS. According to PEMDAS, the P in PEMDAS says, if you have an opportunity to simplify stuff in parentheses, do it. Then move on to exponents. Once again, I'll say that. If you have the opportunity to simplify stuff that's inside parentheses, do that now. Then move on to exponents or whatever else is going on. Well, we do have the opportunity to simplify stuff that's inside the parentheses. We could simplify this, and we could simplify this. So on the next line, we would have, well, what is -4 minus -1? Well, that's -5. So that's going to be -5 squared plus, okay, what is -2 minus 3? That's going to be also -5. How about that? So that's going to be -5 squared. Okay, now that we simplified stuff that was inside parentheses, we've satisfied the P and PEMDAS. Now we're moving on to the E, which says apply any exponents. If you have any. If you have exponents, then apply them now, right? Well, we're going to apply these exponents now. So we still have this huge square root symbol. We have negative 5 squared, which is 25. And then we have negative 5 squared, which is 25, right? And then on the next line, we will very clearly see that that is, of course, radical 50, or the square root of 50. Okay, square root of 50. So, yeah, that actually, you could say, that's the answer. There's always a possibility that that number might show up as an answer choice if you were asked, what's the distance between these 2 points? Well, it's definitely the square root of 50. Now, it is the case that you could plug this into your calculator as well, and if you did that, if you did the square root of 50, you would get approximately 7.07. Okay. Also, it's good to know that this is not fully simplified. Okay. The bottom line is that the square root of 50 is really the square root of 2 times 25, and that could be split up as 2 times radical 25, which, by the way, could also be rewritten as radical 2 times 5, because the square root of 25 is 5. And then finally, you could rewrite that as 5 radical 2. That's usually how they like it. They usually like it where the 5 would be in front and the radical comes next. I say radical, just know that when I say radical, it means the square root of whatever. All right, so we have 5 root 2. Maybe I'll say it that way. That's the simplified version. So really, there's 3 ways of expressing the answer, and that's radical 50, 7.07 approximately, by the way, and 5 radical 2. Now, I will say these are the ones that your teacher would typically like the best. This is considered bad form to leave this in this unsimplified state. You're either going to want to do an approximation or make it simplified like this, typically in your class, in like your actual math class. But you never know. In the SAT, maybe they'll have this as an answer, and you want to make sure that you know that this is the answer. All right, so moving on. Arc length. All right, well, what is an arc? Well, an arc is a piece of the circumference. The circumference is the distance all the way around a circle. Okay, we're dealing with circles now. All the way around a circle, and the arc is a piece of that circumference. That would be an arc, and when they want the arc length, they are basically asking, well, how long is this piece? Okay, well, I think it's helpful to know the formula for a circumference, and that is circumference equals 2 times pi times r. Now, of course, the r is the radius, where it's the distance between the center of the circle and the edge. That's the radius. Okay, and so that is a circumference. Now, you don't have to memorize that because, as you might recall, I showed you the list of formulas that the SAT actually gives you, and this is on that list. The circumference of a circle is 2 times pi times r. Okay, now arc length is really, really easy once you understand like the sort of logic behind the arc length formula. Okay, so this is the arc length formula that at least I would propose, and it's based on this idea of the part over the whole. So what I mean by that is the arc length is a part of what whole? Well, it's a part of the entire circumference, right? Didn't I just say that? Here's the arc. It's a piece of the whole circumference. So down here, the whole is the circumference. But I'm not going to write circumference. I'm going to write 2 pi r. And that equals what we call the central angle. Okay, the central angle, which I'm actually going to write, central angle, and that's, often going to be in degrees. Okay, and I'll discuss what that is. Over 360. Now, what is the central angle? Let's say we did want to find this arc. Well, the central angle is this angle right here. this angle right here that, you know, is between the two radii that encapsulate our arc, okay? Now, if you think about it, it's part over whole. We have the arc length, which is right here, over 2 pi r, which is the entire circumference. And that's going to be equal to the central angle, which is this angle, times the angle all the way around, which is 360. So you can think of this angle going all the way around. That's 360. So once again, part over whole. A piece of the circumference over the whole circumference equals the central angle over a full revolution. Okay? Now, I wrote this part over whole thing, but this isn't really part of the formula. This is the formula. Okay? So I'm actually going to erase this part over whole part. And we are just left with this right here. Okay, so I'm going to erase this right now, and we're going to do a little practice problem. So imagine we have a circle right here, and we have a central angle of 45 degrees, and we know that this right here is 10. Okay, so the radius is 10, and that's a central angle of 45 degrees, and we are being asked to find this arc length right here, the green arc. Well, we just plug in, you know, all of the knowns, and we plug in the unknown. We'll use x to denote the unknown. And I say we just dive right in and plug in, you know, x over the circumference equals, in this case, it's going to be 45 over 360. So it's going to be x over the circumference. Now, let's get this over with. 2 pi r. Well, what is r? R is the radius. So it's going to be 2 times pi times 10, aka 20 pi. If you have to pause it and go back and make sure you understand what I just said, go ahead and do it. But we're going to have 20 pi down below, and then we're going to have equals, and we have the central angle. It is 45. So that's going to be 45 over 360. Now, you don't really have to write these degree symbols because they're just going to cancel out anyway. Like the degree symbol is literally going to cancel out. Now, I will say, though, that we do have an opportunity before we do any cross multiplication here. We do have an opportunity to simplify this right here. So 45 over 360 reduces to 1 over 8. So we could hypothetically rewrite this as x over 20 pi equals 1/8. Now, here's the deal. We could cross multiply. I think a lot of students watching are probably very used to seeing like, oh, a fraction is equal to a fraction. Therefore, let me cross multiply these because that's what I'm supposed to do. That wouldn't be wrong. And by doing that, you would certainly get the answer, you know, assuming you did the rest of the problem correctly. However, we're just trying to solve for x, right? We want to get this x by itself. So the question should always be, okay, well, what the heck's in the way of x being by itself? Well, this 20 pi down below is in the way of x being by itself. If this 20 pi wasn't here, then it would just be x equals blah, 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 and then we'd have the answer, right? Because that's what we're trying to do, trying to find x. X is the arc length. Well, how do we get x by itself? Very easy. You just multiply both sides by that annoying denominator who nobody invited to the party. So you kick that denominator out by multiplying both sides by the denominator. You cancel out the 20 pi, cancel out the 20 pi. Now, I did it over here, which means I have to do it over here. And nonetheless, when you cancel, you end up with x over here, and x equals 2 pi over 8. Now, in case that's not clear, it's because there's an invisible 1 under here. Okay. Invisible 1 over there. And when you have two fractions that you're multiplying together, you just go straight across. So 2 pi times 1 is 2 pi. 1 times 8 is 8. So there we go. Now here's the deal. The 2 and the 8, that could be reduced for sure. The 2 could turn into a 1, and the 8 could turn into a 4. And then, lo and behold, we have pi over 4. Now I know that that's a weird number, but it is the answer. That's actually the arc length right there. All right, it's pi over 4. So I'm going to erase this, and I want you to try. All right, so imagine we had a circle right there, and we had a radius of 3, and then this thing opens to 120 degrees. And we want to find this arc right here. What is the arc length? Good luck. Pause the video. Give it a shot. Let's see if we can do it. Okay, so I believe in you. I think you probably got it. Let's find out. So the central angle clearly 120. The radius clearly is 3. The unknown is the actual arc length itself. So we're going to write x over 2 pi times what? 3. We'll worry about that later. And we have equals 120 over 360. And on the next line, we can write x equals 6 pi. And 120 over 360, that definitely reduces to 1 over 3. Isn't that great? Okay, same deal. We could cross multiply, or we could just multiply everything by 6 pi. So we're going to end up with, as a result of that, let me do that step. 6 pi, 6 pi. Secretly, there's a 1 underneath there. So these cancel. And then you are left with x equals 6 pi over 3. And that equals 2 pi. Hopefully you got that. If you didn't, no big deal. I would suggest just practicing. Practice. Khan Academy. Khan Academy it up. Just type in Khan Academy arc length. Eventually I'll probably have more videos on this kind of thing. But Khan Academy is pretty good. All right, so we have 2 pi as the actual arc length. Now you might not be used to like lengths of anything being written with a pi, but remember pi is just a number. It's like 3.14 blah 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 blah. It's just a number, right? So it's going to be like 6 point something, right? That's how long this thing is. It's 6 point something. Okay, so that is that. Moving on. Sector area, very much related to what we just did because it features circles. You're going to have a radius, radius. But the question is, what is a sector? A sector is the area of what I like to call the pizza pie slice. It's the actual area of this. Now, what's awesome about sector area is there's a lot of similarities with the arc length, like with the formula, where it's once again going to be the part over the whole structure, all right, where we can kind of see how this is a piece of the area. In other words, this has an area, and it's part of the whole area. Well, what's the area of a circle? Area of a circle is pi r squared. That's something you also do not have to memorize because it's given in the beginning of the section. Okay, that's part of that, chart that I showed you in the beginning. So that's the area of a circle, right? So this is a part of the area of the circle. And then there's the whole area of the circle, right? So that is going to be sector area. Therefore, we're going to have sector area all over. And I'll just write out the formula, pi r squared, right? Because that's the formula for the area of a circle, pi r squared. So it's a part of the area over the whole area. And guess what it's going to be equal to? Going to be equal to the central angle over, guess what, 360. Okay, central angle, this angle, that angle right there, over 360, the part over the whole. Notice how this piece of this equation is the exact same part, is the exact same piece as the arc length equation. The only thing that's different is this, right, and this. This formula. With the arc length, this was the circumference, and with the sector area, this is the area. But it's still the part over the whole, right? So it's very logical, okay? So let's imagine we have a circle that looks like this. And we have a radius of 7. And this central angle right here, this is definitely, well, let's say it's 50. And we want to find the sector area right there, right? Well, the sector area is the unknown, so that's going to be an x. And it's going to be all over pi r squared, right? Pi r squared. But we have the radius at 7. So that's going to be all over pi times 7 squared. And that's a little ugly. We're going to get to that soon, but let's finish the rest of this. Is equal to the central angle over 360. The central angle is 50, so it's going to be 50 over 360. Now on the next line, it's going to be x over 49 pi, and that's going to equal 5 over 36 once we reduce that. Okay, now I can already tell it's going to be kind of an ugly answer, but we're on the right track. We set up the formula, we plugged in what belongs there, we got clear, the sector area is the unknown, so that's going to be x. We have pi times 7 squared equals 50 over 360, central angle over 360, and we're just kind of gradually simplifying and moving things along. 7 squared is 49, and we simplified this, we reduced that. Similarly, we're going to multiply both sides by 49 pi right now, and therefore we will cancel out that denominator, right? And that's what it looks like when we do that. And we have x equals, okay, so once again, there is that invisible 1 underneath, the 49 pi. So this is just multiplying straight across. I mean, this is like terrible. It's really like a terrible problem. But, it's going to be sort of unavoidably ugly. That's what happens when I make up problems on the fly. You're going to get some weird answers every now and then. But you know what? You should be okay with that, because as long as you follow the logical progression, you will get the right answer. And this is going to be the right answer. So we're going to have down below, let's take care of the denominator. It's definitely going to be 36 down there, right? I don't see any opportunities, by the way, to cross-cancel here. Certainly there isn't any opportunity to cross-cancel 5 and 1. But there's no opportunity to cross-cancel here, because I can kind of tell, because this is the prime factorization is 7 and 7, and this doesn't have a factor of 7 in it. So there's nothing that can be reduced between these two. So we are sort of stuck with this multiplying straight across situation. I'm going to do a little mental math here. 49 times 5. Well, 50 times 5, right? 50 times 5 is going to be 250. And it's going to be 250 minus 1 times 5. And that's going to be 245. All right. Now, if you don't know how I did it, let's not worry about it. Okay, but it's 245 over 336. I know y'all could do that if you had to, where it's like 49 times 5. You could do it that way. You could also use your calculator, right? So we then have, let's see, we then have 245 over 36, but of course you must not forget the pi, and that is the answer to that one. That's literally the area of this sector right here. Hopefully that makes sense. So as usual, I'm going to erase all of this shenanigans, and I want you to try now to find the sector area of this guy right here. Central angle, very small central angle, 15 degrees. And we do definitely want the area of the blue sector. And the piece of information that I could give you right now is that the radius is 20. Radius is 20. So please pause the video and give that a shot. Once again, we're looking for the sector area. All right, hopefully that worked out for you. So once again, the sector area is x, and it's going to be pi over pi r squared. Now the radius is 20, so that's going to be pi times 20 squared, and that equals the central angle, which is 15 in this case, over 360. So yeah, we have 20 squared right here. Well, that is definitely 400, so we're going to rewrite that part. It's going to be x over 400 pi, and that equals 15 over 360. Now, I could tell off the bat, this is certainly divisible by 5, as is 15, right? So 360 divided by 5 is 72. 15 divided by 5 is 3, so that would be 3 over 72. But here's the deal, 72 is divisible by 3. So here's what I'm seeing. I'm seeing that 360 is actually divisible by 15. That's what I'm seeing. Okay, so you know, if you're not sure about that, you'd have to maybe pause the video, go off to the side, double check that. But the GCF of 15 and 360 is actually 15. You know, the greatest common factor of these two numbers is actually 15. So this is going to become a 1, and 360 divided by 15 is 24. So this ends up becoming 1 over 24. All right, again, pause the video if need be to sort of verify that yourself. But we're going to keep moving because I'm more interested in the general sort of big picture view of how to find the sector area. Multiplying both sides by 400 pi at this point would be a good idea. So 400 pi right here. Keeping in mind, of course, there is that invisible 1 that's under, and then 400 pi over here. And that 400 pi cancels this 400 pi. And we are therefore left with x equals, there is an opportunity to do a cross cancellation with 24 and 400, if for no other reason than the fact that they're both divisible by 4, for sure. 24 divided by 4 is 6. 400 divided by 4 is 100, and that could be further subdivided because those are two even numbers, right? So 100 could turn into 50, and 6 could turn into 3. Okay, so this is really going to end up becoming 50 over 3 pi. Okay, now verify that if you want to. I'm essentially saying that you know, this would turn into 50, and that would turn into 3. And I'm seeing right now that maybe a more succinct way of saying it is because 400 divided by 8 is 50, and 24 divided by 8 is 3. That's another way of saying it. I'm kind of thinking out loud over here. So we have 50 over 3 pi. There it is. Boom. That is the answer. Hopefully you got that. Moving on. Okay. Quadratic equation. What the heck is that? Well, the quadratic equation is this one. This is the nightmare equation that no one likes to look at, no one likes to think about it, but nonetheless, super useful. Okay, now when do you use that? That's the question. When are you supposed to use that? Well, you use that when you have something like x squared plus 3x minus, I don't know, 20 equals 0, right? That is a quadratic equation. It's a quadratic trinomial, meaning quadratic because the highest exponent is 2, and it's a trinomial because there's 3 terms. Okay, so set equal to 0, and we have x squared plus 3x minus 20, and sometimes you're going to be able to factor these things, where it's like this kind of thing, and it would be like x plus blah, x minus blah, right? But occasionally you're not going to be able to factor it. In this case, you can't factor it, and you still need to solve for x. So the question is, how are you going to do it? Well, there's actually more than one way of doing it. One of the ways that's a real tried and true way is to use the quadratic equation where it says x equals all this. Now the question is, what do we mean by b and a and c? Well, as many of you probably remember, the standard form of a quadratic trinomial would be this. Okay, and basically, a is the coefficient in front of the x squared, b is the coefficient in front of x, and c is the constant itself. In this case, our a is this invisible 1 that's in front of the x squared. So we could write that. We could write a equals 1. B in this case is clearly this 3, and therefore b is 3. And c is, got to be careful, up here it says plus c. Well, what are we adding over here? We're adding, in air quotes, a negative 20. Okay? So c is negative 20. Okay? C is not 20. Because c is the number that's being added to this stuff. When we look at this, we're like, well, what's being added to all this stuff? Negative 20 is being added to all this stuff. So c is negative 20. All right. So it's going to be x equals negative, again with my parentheses. I'm just going to draw those first. And even though it might seem a little clunky, it's a good way of avoiding careless mistakes, especially with negative numbers, which you're going to see soon. So this is negative b. So what is b? Well, we already wrote it. B is 3. Okay, so that's 3. And then that goes here as well. A and C. Well, what's A? A goes right here. A is 1. And A also goes down there. We have an A down there. We have a C right here. And there it is. And C is negative 2. So this is the first time where we're really seeing why the negative in parentheses is a better way to go. Why using parentheses is a good way to go, because you can very clearly see it's a negative 4 times a positive 1 times a negative 2. Now we know that negative 4 times a negative times a positive is going to be a negative times a negative is going to be a positive. That's going to come into play later. So let's simplify this. We have x equals negative 3 plus minus, and then we're going to have 9. And here's where that comes into play. Again, a negative times a positive. Negative 4 times positive 1 is a negative 4. But a negative 4 times a negative 2 is a positive 8. So you just write plus 8. Okay? That's huge. That is huge right there, what we did. Again, let's think it through. Negative 4 times positive 1 is a negative 4. Negative 4 times negative 2 is positive 8. So you just write plus 8. Okay, that's the way to think through that part. And then we have 2 times 1 is 2. And moving on, we've got x equals negative 3 plus minus root 17 all over 2. Now that is an ugly situation for a number of reasons. We have this huge square root symbol. We've got a huge, big denominator underneath. Not only that, but we got plus minus. Like, what the heck does that mean? Well, that means essentially that there's two answers. You have negative 3 plus root 17 all over 2. And you also have negative 3 minus root 17 all over 2. So that's actually two answers right there. Now, the bottom line is this could also be rewritten in such a way that this denominator applies to the negative 3, and this denominator also applies to this term over here, the root 17. So the truth of the matter is this equals negative 3 over 2 plus minus radical 17 over 2. Again, ugly situation, but unfortunately you do have to kind of get used to the fact that you might end up with an ugly situation like that when you're doing the quadratic equation. All right. If you ended up getting like these nice clean numbers, then that means that this would have been factorable in the first place. The fact that this is not factorable in the first place means you're probably going to get kind of like a weird situation over here. All right, so that's how that works. I am going to erase this as usual and give you a chance to try this. I'm going to leave the quadratic equation here, and I'm going to leave this here, and I expect you to get the correct answer on the next problem. Okay, so the next problem will be x squared minus 3x minus 1 equals 0. So please pause the video and give it a shot. All right, so first thing to do, get clear about what is your A, what is your B, and what is your C. So A is the invisible 1 that's in front of the x squared. And then we have B, which is a negative 3. And then we have C, which is a negative 1. Okay, so then I go in here and I fill in the structure. Squared minus 4AC all over 2A. And then I put in what belongs there. So, starting with B, B is negative 3. Negative 3 goes in these places, and then A is 1, that goes here, and then C is negative 1. Okay, so on the next line we have x equals negative 3, which is a positive 3, plus minus 9. Now, because negative 3 squared is 9. So we have a negative 4 times a positive 1, which is a negative 4. A negative 4 times a negative 1, which is a positive 4. So you just write plus 4. All right? Pause, rewind if need be to be reintroduced to that line of thinking. And then we have all over, clearly the 2 times 1, so that's going to be 2. And then we have x equals 3 plus minus root 13 over 2. That could be rewritten as 3 over 2 plus minus root 13 all over 2. Hopefully that makes sense. Moving on. All right, so now we move on to averages. Now, averages is something that everybody who's watching this has definitely learned at some point. The mean is the average that pretty much everybody is used to at a certain point in their math education process. That's where you take the sum of all the terms. So for example, if it's test scores, you add them all up and then you divide it by the number of terms or the number of tests in general. Average speed, a little bit less known to the average student, no pun intended. Average speed, total distance over total time. So let's cover each of these. I'm going to provide an example for each of these. Let's start with this one. So let's say we have a test score of, let's see, 84, 90, and we'll say 91. And you're going to be taking a fourth test, and you want to make sure that you get an average of, let's see, you want to make sure that you get an average of 92. So our target average is 92. And that's the average for all 4 tests. Okay? But so far you got an 84, you got a 90, and 91. So the question is, what do you need to get on the 4th test in order to get that average of 92? So yeah, basically with that one, you would literally just use this formula, okay? The mean or the average equals the sum of terms all over the number of terms. Well, we have the target average. So we're actually going to put it right there, okay? So this is going to be 92. That's the average that we're shooting for. And we're going to get that 92 by adding all the test scores, all these, and dividing it by 4, right? Because we're going to be doing 4 total tests. They actually write the 4 there. And we want to know what you got to get for that 4th test. Well, obviously, we're going to be adding, you know, the previous 3 test scores. It's going to be 84 plus 90 plus 91 plus x, which is the 4th test score. And then you would solve this equation. Now, I'll solve this for you guys because for those of you who feel as though you could use a little more practice with algebra, it's probably going to be good to see how to solve an equation like this. So the first thing you want to do before you solve any algebra equation is simplify both sides. And sometimes that might require you simplifying a numerator or a denominator if there's an opportunity to do so, if there's a fraction. And it is the case that we could simplify this numerator here. These are all like terms. They could certainly be combined. So 84 plus 90 plus 91. Well, 90 plus 91 is 181. 181 plus 84 is going to be 265. All right, so on the next line, I could even write that. I could say 92 equals 265 plus x all over 4. And we've got to get rid of this 4 down here. We want to get x by itself, but we got to get rid of this denominator first. Then we'll subtract 265 from both sides. So to get rid of that 4, we've got to multiply both sides by 4. Boom. And then from there, it's 265 plus x. 92 times 4, 90 times 4 is 360. 2 times 4 is 8. So we're looking at 368. So that's a little mental math. Use your calculator if need be. Subtracting 265 from both sides. 265 from both sides. Let's take a look. We end up with x equals 301. So we are praying that there will be extra credit on this next test because in order to get a 92, it's really this 84 screwed everything up. So in order to yank the whole average up to 92, we got to get a really high score over here, especially because of that 84. That 84 really screwed us up. So we're going to assume that you can indeed get extra credit on the test, and you need a 103 for that one. Okay, so please do the following problem and try it yourself. So imagine you had, we'll stick with test scores, imagine you had a test score of 72, 60, and we'll leave it at that. So what do you need on your third test for the marking period in order to pass? Okay, now passing is when you get a 70. Okay, let's just say, what's the lowest score you need on this third test in order to pass the class if 70 is the passing grade cutoff? So go ahead, pause the video, give it a shot. All right, so 70 is the passing grade cutoff, so we are going to use this formula where 70 is the target average, and then we just fill everything in. So we're going to have 70 equals, well, it's going to be 3 tests total, right? It's going to be 72 plus 60 plus whatever you got for that third one, right? And from there, we could simplify that numerator. We're going to have 70 equals 132 plus x equals, or over 3, multiplying both sides by 3, and that would cancel. We end up with 132 plus x equals 210, and then subtracting 132 from both sides. Well, 210 minus 140 is 70, so it's going to be 78. All right, so you need at least a 78 for a passing grade. Okay, so hope you got that, and let's move on to average speed. So average speed, total distance over total time, that could be a tricky one because a lot of students make the following mistakes. So imagine you had a car, and you're going to work at 40 miles per hour, and you come home at 60 miles per hour. And imagine they ask you, what's the average speed of the whole trip there and back? Well, a lot of students would, add 40 plus 60 and divide by 2, they would get 50. They'd be like, well, clearly the average speed was 50 miles per hour. And that is wrong. Okay, that is very wrong. For a problem like that, you need to take into account the fact that the average speed is the total distance over the total time. So that means you need the total distance and you need the total time in order to figure out the average speed. So the question is, how do you do that? Well, the key is to recognize that rate times time equals distance. Okay, and you can make this little box here. This is how I like to do things. And this represents your trip to work, all right, to work, and this is your trip back home from work. Now, according to the information, you go 40 miles per hour to work, and you go 60 miles per hour back from work. But then the question is, okay, what is the time spent? What's the distance? Well, the good news is we actually can pick a distance, like how far it is to get to work. Maybe it's 100 miles, maybe it's 200 miles to work. That'd be terrible. But, we could pick a distance because the bottom line is the distance has a proportional relationship to the time. The bigger the distance is, the bigger the time is going to be. So it should all sort of work out in the end. The smaller the distance, the smaller the time is going to be. And, so the more this expands, the more this is going to expand, and the more this shrinks, the more this is going to shrink. So there is that nice proportional relationship, and because of that, we can actually choose the distance. Now, the distance that I'm going to choose is something that's divisible by both 40 and 60, which is why, in my opinion, 120 is the perfect distance to work, and of course, the distance back from work is 120. Okay, now, once we've sort of made that up, we could then figure out what the time is. Well, if rate times time equals distance, which it always does, 40 times what gives me 120? Well, clearly that's 3, so that's going to be 3 hours. Okay, 3 hours because we're dealing with miles per hour. So distance is miles and time is in hours. So we have 3 hours right there. And then over here we have 2 hours, right? So we just set up this nice little table that should really help us, figure out what the average speed is, because we can now figure out the total distance. We can now figure out the total time. Total distance, well, that's just 120 and then 120. We went 120 miles there. We're going 120 miles back. So obviously that's going to be 240, when we add it, right? And the total time is obviously 3 hours there, 2 hours back. So that's a total of 5 hours. So if you want the average speed, it's got to be the total distance, also known as 240, over the total time, also known as 5 hours. So that is going to be 240 over 5, and that will definitely give you 48 miles per hour is the answer. That's the average speed that you drive to work. All right, so it's not 50, it's 48. So you do have to be careful with that. All right, practice problem for you. So imagine you drive at a snail's pace at 30 miles per hour to work. We'll say 2. And from work, you go 200 miles an hour. Okay, so what's the average speed? Pause the video, give it a shot. Average speed for the whole trip there and back. What is it? Good luck. All right, once again, I would strongly suggest using that chart. We have rate times time equals distance. And the first row will be 2, and this is from. So 30 miles per hour on the way there, 200 miles per hour on the way back. I'm going to want to find a distance that's divisible by both 30 and 200. So I'm just going to go with 600 because I know that that would totally work. So 600 miles to work, 600 miles back from work. And in order to get to work, that's going to be 30 times what gives me 600? Well, that's 20. So it actually takes 20 hours to get to work. That's miserable. And then we have 600. So 200 times what gives me 600? So that's 3 hours. So it's a 3-hour ride back. How about that? Crazy. So 600 plus 600 is 1,200. And then we have 20 plus 3 is 23, right? So we're totaling up the distance, totaling up the time. So it's going to be total distance over total time. So that's going to be 1200 divided by 23. And that is approximately 52.2. How about that? Miles per hour. Okay, so I hope that was helpful. Moving on. Probability of an outcome. Okay, so the probability of an outcome is always going to be the desired outcome over the possible outcomes. For example, imagine we have, we're going to go with the classic bag with marbles in it thing. This is a bag, okay? And we have, 3 blue marbles. We're going to have 1 red marble. And we have 3 green marbles. What are the chances? What's the probability of pulling out a green marble? Well, it's desired outcomes. How many desired outcomes do we have if we're going to try to pull out a green marble? Well, there's 3, right? So it's going to be 3 over the possible outcomes. Well, how many possible outcomes are there? Well, it's going to be 7 because there's 7 total marbles, right? So it's going to be 7. All right, that's probability right there. Now that was a very rudimentary problem, okay? Probably most of y'all destroyed that problem in your head. I am going to give you the sort of problem that you might have to deal with on the SAT, specifically when it comes to probability stuff. All right, and I'm going to challenge you. We're going to challenge you right out the gate and see if you can do it. All right, the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people, Group X, that's right here, who observed early bedtimes. Group Y consisted of 100 people also, that's Group Y, that row, who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what's the probability that the person belonged to group Y? So it's good to look at this. These are the, this column represents the amount of people from each group who didn't recall any dreams. This is the column that represents the amount of people who recalled 1 to 4 dreams, 5 or more dreams in this column. So please pause the video and try this one. And when you unpause it, I'm going to tell you how to do it. All right, so really the first thing to do is, again, get clear on what's even being said, and then you have your totals down below. I kind of explained, group X, these are the people who had early bedtimes, group Y had later bedtimes, and in my opinion, it's going to be really vital to get clear on what they're asking for. So if a person's chosen at random from those who recalled at least one dream, so that's the population that you're pulling from. So we're pulling from this whole population. It's the people who recalled at least one dream, right? We're not paying attention to these people. Okay, what's the probability that the person belonged to group Y? Well, the question is how many people are in this group. That's going to be the possible outcomes. And then we want to know the desired outcome, which is that the person belonged to group Y. It's going to be desired over possible. So the possible outcomes are all the people that we could choose from. Now, there's really 2 ways of doing it. You could literally add all 4 of these numbers up, or you could just add 39 plus 125, right? Because this is the total of this column. This is the total of the other column. You could just add them. So when you add them, you get 164. So I'm going to put that down below because that's how many people we're dealing with, which corresponds with the possible outcomes. But we want to know the desired outcome, which is, the person belonged to group Y. Well, where is group Y? Group Y is right here, right? So group Y is this little section right here. So we have the total population in yellow, and we're honing in on the desired outcome of this green box. So that's 68 plus 11. 68 plus 10 is 78. 78 plus 1 is 79. So that's going to be 79 right there. So that is the answer, which is answer choice C. Moving on. Okay, percentages. This, you might want to get used to the is over of approach. So there's is over of. And that's going to be equal to the percent over 100. If you could find a way to remember this, you could also think of it as part over whole. But a lot of people like is over of. So what I mean by that is, the word is and the word of are represented in each of these, okay? So I'll do is in red, I'll do of in blue. And when we're talking about is over of, we'll focus on is first. Is the number that's to the left of is, or next door to is. But it has to be the number or word that's not a percentage, because the percent is always going to go here. So it's the number or word that's next door to the word is that is not the percent. So in this case, it's the word what. Now, of is the number or word that's next to of that's also not the percent, and that's going to be right there. So, for example, for this one, it's like, what is 2% of 30? Well, that's going to be is over of, so that's going to be, first of all, the what is an x, because we don't know what it is, so that's the unknown. So that's going to be x over of, and of is 30. And that's going to equal the percent, which is 2 over 100. Okay, so that's the setup. Now we want to solve for x, and we could do so by multiplying both sides by 30. And in doing so, we cancel these, and we end up with x equals, let's see, this could cancel with the 100. The zeros would cancel, at least. So it'd be 2 times 3, which is 6 up top, all over 10. And it still happens that that could be reduced further to 3 over 5. So that's actually the answer to that one. Once again, all we really did was use this is over of equals percent over 100. I'm going to actually let y'all try each of these, okay? So pause the video and try this one. Again, is the word or number next to the word is, that's not the percent. Of is the word or number next to the word of, which is not the percent. And anytime you see like what or what number, that's the unknown, so that's going to be x. Okay, so pause the video and give it a shot. At least this one. All right, hopefully you tried this one and it worked out. That is going to be 12 over x equals 6 over 100. And the reason for that is because is 12, because 12 is the number or word next to the word is, that's not the percent. And x corresponds with of, because of is the number or word next to the word of, that's not the percent, so it's right there. Now this is a little tricky. This one you definitely do have to sort of cross multiply it, okay? And in cross multiplying we go 12 times 100 equals 6 times x. So that's going to be 1200 equals 6x, dividing both sides by 6. I'm just going to kind of do it, and that's going to give you 200. All right, so hopefully that makes sense. Please pause the video and try this one. All right, hopefully that worked out for you as well. Let's take a look. So, is over of, is 15. Of is 550. What percent? That's the unknown. The percent is the unknown. So that's going to be x over 100. And really, to solve for x, all I got to do is multiply both sides by 100. So I'm going to do that right now. We're going to have 100 times 100. Cancel, cancel. We end up with x equals. So 100 divided by 50 is 2, and 550 divided by 50 is 11. So this turns into a 2, and that turns into 11. All right, you can always verify that later if need be. I'm going to do a little divider here. So that's going to be 2 times 15 is 30 over 11. So that is 30 over 11. Now I'm going to be cool with this as the answer. Now we all know that that's going to be like 2 point something, okay? But we can leave it like that. All right, so 15 is what percent of 550? Well, it's 30 over 11%, okay? So it's like 2 point something. All right, so that's how that works. Moving on. All right, trig stuff, meaning trigonometry stuff. Now, trigonometry has to do with right triangles. So here's a right triangle. Let's imagine it's 3, 4, 5. And let's imagine we are analyzing this angle right here. Now, that little symbol right there kind of looks like a 0, but it's like swoopy. Swoopy instead of like a line going straight through. That's called theta. Okay, it's a Greek letter, and it's often used to denote various angles in triangles, especially once you get to trigonometry. So anyway, when it comes to the trig stuff that you need to know for the SAT, Definitely it's good to know this, SOHCAHTOA. It's kind of an interesting word, easy to memorize, and basically what this means is SO stands for the sine of theta equals opposite over hypotenuse. So the S in sine and then OH, S in sine, OH. And cosine of theta, and I'll explain what this means in a moment, equals adjacent over hypotenuse, and this is the tangent of theta equals opposite over adjacent. So meaning SOH, well, S in sine, OH, CA, CAH, C in cosine, A and H, and TOA, T for tangent, and O over adjacent. Now, the O stands for opposite, the H stands for hypotenuse, I'll just write that, the A stands for adjacent. Okay. So that's how this works. Now you might be asking, well, what's the point of these? Well, bottom line is, if you're dealing with a right triangle, these ratios will apply to a lot of problems. So the sine of an angle, if you're dealing with a right triangle, that is, the sine of an angle will always be the ratio between the opposite side and the hypotenuse. Now the hypotenuse, which is right here and right here, that is always going to be the longest side. Okay, that's going to be the longest side. And let's say we're analyzing theta and we talk about sine of theta is opposite over hypotenuse. Well, here's theta, and the opposite is the side that's all the way across the triangle. Okay, so in this case it's 3. So the sine of this theta is equal to 3 over 5, because again it's opposite over hypotenuse. The cosine of this angle theta is equal to the adjacent over the hypotenuse. Now the adjacent is the next door side. It's the side that's right next to the angle that you're looking at. So we're looking at theta, which is this angle right here. So the adjacent side is 4. So the cosine of theta would therefore be 4 over 5, because once again, the length of the hypotenuse is 5. And finally with tangent, the tangent is going to be opposite over adjacent. So here's theta, the tangent of theta is opposite over adjacent, here's theta, opposite is 3 and the adjacent is 4, so that's going to be 3 over 4. All right, now these are ratios that are definitely applicable to a lot of problems in trigonometry, and as an example, here is an example. Imagine you had 30 degrees and you had this right here, and you also had 60 as the length of this hypotenuse right here. And so when it comes to a problem like this, what you could do is use your calculator, where you basically ask yourself, okay, well, what's the angle in question? It's this 30 degrees. We have an opposite side and a hypotenuse. What does that remind me of? Opposite side and hypotenuse. That reminds me of SO, because its sine of theta is opposite over hypotenuse. So what you could do is you could set up an equation. All right, I'm kind of illustrating how these trigonometric functions can be useful. You set up an equation where it's sine of 30, because it's always sine of an angle. Okay, it's always going to be sine of an angle. Now, to be clear, that's not sine times 30, that's sine of 30. And that equals opposite over adjacent, x over, opposite over hypotenuse, I should say. It's x over 60. And what's awesome is you could use your calculator to figure out what sine of 30 is and kind of take it from there, and you could actually solve for x. Okay, so the calculator is very helpful when you're doing trigonometry. So what I would do is, even before like doing the calculator, is I would multiply both sides by 60. That would cancel these, and then we have x equals 60 times sine of 30 degrees. Now let's be very clear, the sine of 30 degrees is itself a number. That's one of the reasons why I put the 60 to the left, because I don't want the 60 to be over here, because it might look like it's going to be sine of 3 1006, right? We want the 60 on the left-hand side because this is a number in and of itself. In fact, we're going to find out what that is on the calculator, and then once we do that, we can multiply it by 60, and then we would, have the answer. So I'm actually going to figure out what sine of 30 is right now. So the sine of 30 is 1/2, so we're going to write that. It's going to be 60 times 1/2, and we all know that's going to be 30, and that equals x. And yeah, so we have x equals 30. So this length right here is 30. Not 30 degrees, but 30, units of length. This is 60 units of length. This is an angle measurement called 30 degrees, okay? So that's an example of how to use trigonometry to figure out some unknown side length, okay? So I'm going to erase all this. I'm going to leave this up here, even though it's kind of a mess. And I'm going to give you guys a problem to try. All right, so imagine we have this triangle right here, and we have, this is 7, and we want to know what this length is right here, x. So pause the video, give it a shot, and unpause it to find the answer. All right, so hopefully you recognize that we have an angle here, and we have an adjacent side, and we have a hypotenuse. So to me, it's always a good idea to get clear on the cast of characters in the problem. And again, the cast of characters are an angle, an adjacent side, and a hypotenuse. Well, the angle is, theta in this scheme. But it's really the adjacent and the hypotenuse that are the stars of the show. So I see adjacent hypotenuse here. Sine doesn't have it. Sine has opposite hypotenuse. Tangent has opposite adjacent. Adjacent hypotenuse is the cosine function, okay? So what we're going to do is set up an equation called the cosine of the angle, in this case it's 50 degrees, equals the adjacent, which is 7, over the hypotenuse, which is x. All right. Now, this is kind of a tricky little situation where the variable that we're trying to solve for is x. And it's on the bottom, it's in the denominator. And I'll just give you a trick of the trade. Whenever you have a variable down here and it's just a fraction over here, and the variable you're trying to solve for is only in the denominator here, and you have some number over here, because cosine 50, to be clear, that's just a number. It's something that you could plug into your calculator. In fact, we're going to do that. But it's just a number, okay? It could be 10 or whatever. What's pretty cool about this setup is you could swap out the x with this number. Okay, so there's this interesting relationship where you could switch those, and then you end up with x equals 7 over cosine of 50 degrees. And that, in a sense, is the answer. However, we are going to use our calculator. It's going to be 7 divided by the cosine of 50 degrees. Okay, now if you're using your iPhone calculator, you might have to figure out the cosine of 50 degrees first. It's going to be a decimal. And then you take that decimal and you divide 7 by that decimal. I'm using Desmos calculator, which is a graphing calculator. And what's good about that is I could just kind of enter it as 7 divided by cosine of 50, which I'm doing right now. 7 divided by cosine of 50. By the way, if you're using a graphing calculator, make sure that you are in degrees, not radians, degrees. Okay, so this turns out to be 10.89, and that's really approximately, okay, it's approximately 10.89. So that is an example of some of the trig stuff that you're going to need to know for the SAT. So I hope this was helpful. Again, a very brief, well, it's not actually brief, turned out to be a long video. That always happens, by the way, but yeah, so nonetheless, it is a summary of the general sort of facts and formulas that are going to come into play, other than the ones that they give you in the reference guide. I think it's important to go over this, before the SAT, one or the other. Nothing beats practicing the actual problems that you're going to find in the SAT, the kinds of problems, whether it's from the actual College Board Study Guide or Khan Academy is a great resource as well. and working with a tutor who knows what they're doing, such as myself, is going to be very helpful as well, because you really want to keep the questions as close to the SAT as possible. Nonetheless, knowing these facts and formulas is crucial, because these will come up for sure. All right, so you definitely need these concepts. So anyway, hope it was helpful. Good luck on your SAT. If you want to do Skype tutoring, things like that with me, that's sagemathtutoring.com. Check it out, reach out to me, and we will work something out. And take care. Bye.